finished that problem where we flipped a coin randomly, kept the same bet, and because our opponent didn't run out of money, but I guess they had more money than we did. They maybe had infinite money, but they had a lot more money than we did. We ran out of money. I thought it'd not only be interesting to look at the simulated number of times it took to go broke here, but during the simulation, what was the highest amount of money that we had? And it's kind of a simple modification we can make to the function. So we not only want to return the count, but we want to return the maximum amount of the money. Now, the naive way to do this would be just monies. You could put a list in here, and at the end of each one, you could just say monies.append money. And we could return the count and the monies in a tuple. And let's run. Let's just run 100 examples. We're going to use the NumPy random function because it ran quicker, in my opinion. And so let's just run that. Well, now it's not running so quickly, but give it a moment. All right, it did run. Now let's just take a look at the sims np while. Just look at the first record. Actually, yeah, I mean, this could be a big record depending on the length of it. So really, you know what, we could actually just return the max of the monies. We know the min will be 0. So let's run that again. And then if we want to analyze the maximums that we did earn during the 100 simulations, we could just say x1 for x in sims.npy. And we could see how much money we ultimately accumulated here. So we could maybe look at it in sorted order just to get a better sense. 9 was the best one. Interesting. If we go all the way down, $3,600. That's interesting. You know, that's kind of funny because what this is saying is you could just keep placing random bets out there in the world starting with $10. And you could end up with $3,600 with absolutely no skill. But, I mean, look how infrequently that happens. Most people in the world are kind of like us. We just have $9, $10, maybe $20. Some of us have like $40. But, man, you could be pretty stupid and just keep trying and end up with a ton of money. From a runtime standpoint, given that we're running a very, very tiny simulation, this isn't bad. Just keep track of all the outcomes and then return the max of the outcome. I don't think that's really bad. The one thing that somebody might critique about, the runtime of this, or maybe not the space requirements of it or the memory requirements to run the simulation one time, is that you're accumulating a list in memory. And, maybe instead of doing that, in order to come up with the max, you could set like max money is equal to money, so it gets set to 10. And then you could say something at the end of the while iteration. You could say if money greater than max money, max money equals money. And maybe if we return max money, recode that, run it 100 times. Well, that ran quick. We could just take a look at the maxes here. And yeah, you kind of see a similar thing where there are lots of lots of pretty low values, but then somebody out there has got 700, 1,700 bucks. So the benefit here, is that you're just kind of keeping a track of. In my opinion, this is a lot easier to understand. You're just keeping track of them all, then calling max. But you can just use these kind of like flags and in loop variables. So if the money you have is greater than your max money, then obviously you want to update the value of your max money to be equal to money. So, that has it. Figured that might be kind of an interesting segue, or at least pivot on the prior video. So hopefully I like that. See you dudes.